Hi everyone, I'm Cheryl. When we measure angles, sometimes we measure the angles in degrees and other times in radians. In this particular problem, all of our angles are measured in degrees, but we would like to convert them to radian units. So before we begin, we need a conversion factor. How do you go from degrees to radians? Well, we know that one complete revolution, when you measure in degrees, is 360 degrees. And we know that one complete revolution, when you measure in radians, is 2 pi. So 360 degrees is the same thing as 2 pi radians. To create a conversion factor, what we're going to do is we're going to take this particular equation and make it equal to 1, make one side equal to 1. So because I'm going to want to go from degrees to radians, what I'll do is I'll divide both sides of my equation by 360 degrees. So when I do that, I end up with 1 equals 2 pi radians divided by 360 degrees. I'm going to write that out, DEG, for degrees. Now this particular fraction can be reduced, and it reduces to pi radians divided by 180 degrees. All right, so let's use this conversion factor to help me convert from degrees to radians. So in my first example, I have 30 degrees. Well, 30 degrees can be written as 30 degrees times 1. Now we know that 1 is the same thing as pi radians over 180 degrees. So I can write this as 30 degrees times my conversion factor, pi radians over 180 degrees. Now notice what happens. The degrees will cancel, and I'm left with 30 times pi radians all over 180. Now this fraction will reduce. I can divide both the top and the bottom by 30, and I end up with pi over 6 radians. So in other words, 30 degrees and pi over 6 radians measure exactly the same angle. Okay, let's try it again with a different angle. This time I have 150 degrees. Well, again, I can write this as 150 degrees times 1. Because of my conversion factor, I know that 1 is the same thing as pi radians over 180 degrees. So I'll write this as 150 degrees times pi radians over 180 degrees. Once again, the units that are degrees cancel, and I'm left with 150 times pi radians all over 180. Okay, again, if you look at this fraction, 30 divides evenly into both the top and the bottom, and we end up with 5 pi over 6 radians. All right, one more time, 315 degrees. It's the same idea. So we'll start out with 315 degrees, and we're going to multiply by 1. So I have 315 degrees, and my conversion factor is pi radians over 180 degrees. My degrees cancel, and I'm left with 315 pi all over 180 radians. This time I can divide 45 into both the top and the bottom, and I end up with 7 pi over 4 radians. Last example, 120 degrees. So I've got 120 degrees times 1. I have 120 degrees. We know now that my conversion factor is pi radians divided by 180 degrees. Once again, my units of degrees will cancel, and I'm left with 120 pi radians all over 180. This time the fraction can be reduced by dividing both the top and the bottom by 60. And so we end up with 2 pi divided by 3 radians. Now, there's one more thing we want to do in this problem. The exercise asked us to write each of our answers in decimal form as well as using factors of pi. So I'm going to pull out my calculator for this. And let's go ahead and get an approximation for pi over 6. So pi divided by 6 is approximately 0.524 radians. 5 pi over 6 is approximately 2.618 radians. 7 pi over 4 is approximately 5.498 radians, and 2 pi over 3 is approximately 2.094 radians. Sometimes it's nice to have the decimal approximation, but remember, when you use a factor of pi, you have the exact answer. I hope this was helpful. Thanks.